In this lesson, you will learn how to obtain inverse matrices using two different methods. If matrix A and B are square matrices with n by n matrices, then matrix B is the inverse of matrix A if and only if the multiplication of A and B equals to the multiplication of matrix B and A produce identity matrix, which is I. So I here is represented as identity matrix, where the diagonal is equals to 1. So let's say we have an example given that A is equals to this 3 by 3 matrix and B is equals to this 3 by 3 matrix. Calculate AB and find the inverse of matrix A. So first is that we find the multiplication of AB, and the final answer will be equals to 1 0 0 0 1 0 0 0 1, where this matrix is equals to identity matrix. Since AB, multiplication of matrix A and B, produce I or identity matrix, then we can say that our matrix B is the inverse of matrix A. So here we can represent as inverse matrix A equals to B, which is equals to this. So A times with inverse of A is equals to identity. There are two methods to find the inverse matrix. The first one is using elementary row operation, or we can simplify it as ERO. And the second one is using adjoin method. For the first method, I'm going to show you is the elementary row operation, or ERO. In order to find the inverse of a square matrix using ERO, let us see this relationship where the multiplication of the inverse matrix of A times with matrix A is equals to identity. So from here, if we bring this inverse matrix of A to the right side, this will be the inverse of the inverse matrix A. So finally we will get A is equals to A times with identity matrix. So what we want to do is that we can write our multiplication of AI, where A is equals to AI from the previous equation just now. So we can write our AI in the form of augmented matrix, that is in terms like this. The elementary row operations will be carried out until we get a new augmented matrix in terms of I, B matrix. So now we can see that our matrix B is the inverse matrix of A, or we can write it as I inverse matrix of A. So now let us try this example. If given A is equals to 5, 3, 2, 1, find the inverse matrix of A using ERO method. So our aim is to perform the elementary row operations from the augmented matrix of AI to be in terms of identity matrix with B, where B is represented as our inverse matrix of A. So for the first step is we write the augmented matrix. So this will be our matrix A, which is 5, 3, 2, 1. And this is the identity matrix, which is 1, 0, 0, 1. Then we perform the elementary row operation. For the first part for the first step is that we want to make sure that this element will be 0. So first is we focus on the second row. So we want to make sure that this will be 0. So in order to do this is that we have to multiply the second row with 5. So we get 10 minus with 2 times with the first row, which is 5. So here we will get 5 times 2 minus 2 times row 1, which is 5. So here we have our second row, first element is 0. Then we perform the same formula to the next column. So the next column will be 5 times with R2, which is 1, minus with 2 times with row 1, which is 3. So here we have 5 minus 6, which will be minus 1. So the second row, second column will be negative 1. Then we perform to the next column. So here will be 5 times 0 minus with 2 times with row 1, which is 1. Here we have negative 2. And the last column, which is fourth column. So here will be 5 times with 1 minus with 2 multiply with row 1, which is 0. So here we have 5. So now we have completed the second row. Next is that we want to make sure that this element will be 0. So in order to to get this element is 0, so we can add this row, which is 3, which we represent as R1, plus with R2, which is negative 1, times with 3. So here we will have 3 plus 3 times negative 1 equals to 0. So for this column, we will get 0. Then we use the same operation for the rest of the row for 5, 1, and 0. So we just substitute 5 into the operation. So here we have 5 plus 3 times R2, where R2 is 0. So still we get the same answer, which is 5. And then we proceed to the third column. So we have 1 plus 3 times negative 2, which will be equals to negative 5. So here we write negative 5. And then the last column will be 0 plus 3 times with 5, which will be equals to 15. So for the first row, we write the answer that we get from this operation. And for the second row, we just copy from this matrix. The last step is that we want to make sure that this element diagonal is equals to 1. So in order to do this, is just that we divide the first row with 5 and we get 1, 0, minus 5 divided by 5 will be negative 1, 15 divided by 5 will be 3. And our second row must be multiplied with negative 1 so that this element will be 1. So here we have 0, 1, 2 and negative 5. So here, this matrix we already get in terms of identity matrix and another matrix where this matrix is represented as the inverse matrix of A. So the inverse matrix of A is given by negative 1, 3, 2, negative 5. Now let us see how to solve the inverse matrix of 3 by 3 matrix using ERO method. Here what we need to do is we have to write this matrix in terms of augmented matrix. So we want to change from AI to IB, where this is equals to I inverse matrix of A. So our A is given by this matrix. So I just rewrite this 1, 0, 0, 2, 2, 0, 1, 0, 3. And the identity matrix of 3 by 3. So here we'll have 1, 0, 0, 0, 0, 0, 1, 0, and 0, 0, 1. So what we want to do is that we want to make sure that our element, except for diagonal, is all equals to 0. So for the first step is that I'll make this element in row 2 as equals to 0. So in order to make sure that this element is equals to 0 is R2, the row 2 here, minus with 2 times with R1. So for the first row, we just rewrite all the elements in the first row. And then for the second row, we use this formula. We perform these swap operations in order to get the new row. So here we have 2 minus 2 will be 0. And then for the second element, 2 minus 2 times 0. So we have here 2. And then for the third column, 0 minus 0, which is 0. And then for the fourth column, we have 0 minus 2 times 1. We have negative 2. 1 minus 2 times 0. We have 1. And the last column will be 0. Then we write for the third row, we just rewrite all these elements. Okay, the next step is that we want to make this element is equals to 0. So in order to make this equals to 0, we can minus with the first row. So here, our third row minus with the first row. So the remaining row will be the same. So we just rewrite for the first row. And then for the second row, there's no changes. But for the third row, we use this operation. So the third row minus the first row will be 0. 0 minus 0 will be 0. 3 minus 0 will be 0. 3 minus 0 should be equals to 3. And then 0 minus 1 is negative 1. 0 minus 0 is 0. And the last column will be 1 minus 0, which is 1. Okay, now we can see that all the elements apart from the diagonal is equals to 0. So what is remaining is that we will have to make sure that the diagonal is equals to 1. So in order to do this, our second row must be divided by 2. So we just rewrite the first row. And then for the second row, divide by 2. So here we have 0, 1, 0, negative 1, half, and 0. And for the third row, must be divided by 3 so that we get equals to 1. So here we have 0, 0, 1, negative 1/3, 0, 1/3. So here, our matrix here becomes the identity, and this will be the inverse matrix of A, where we can write it as inverse matrix of A is equals to 1, 0, 0, negative 1, half, 0, negative 1/3, 0, 1/3. The second method is adjoin method, where this method can be used to find the inverse of matrix. Adjoin method is a transpose matrix obtained by interchange every element of Aij with the cofactor and denote as Adj of A. Here we have a properties where if we find the determinant of A, of matrix A, is not equals to 0, it means that the inverse matrix exists. Therefore, in order to find the inverse matrix of A using adjoin method, this is the formula where the inverse matrix of A is equals to 1 over determinant of A multiplied with adjoin A. So there are 5 important steps to calculate the inverse of A by using adjoin method. The first step is you have to calculate the determinant of A. If A is equals to 0, stop the calculation because it means that the inverse does not exist. But if the determinant of A is not equals to 0, then we continue with step 2. For step 2, we calculate the minus of A, where we have to delete the ith and the jth row. And then we calculate the cofactor matrix, where the formula of cofactor matrix is equals to negative 1 to the power of I plus j multiplied with the minus of ij. The fourth step is find the adjoint matrix by finding the transpose of the cofactor matrix. So from this cofactor, we find the transpose to get the adjoint matrix. And finally, substitute the results from step 1 to step 4 into the formula in order to find the inverse matrix. So here is how to find the cofactor of matrix. So given the cofactor of Aij, where we represent cofactor as Cij. Cij is the product of -1 to the power of I plus j times with minor matrix. So it can be summarized that here is A11. So 11 will be -1 to the power of 1 plus 1, which will be positive, times with the minor matrix. And for the second column and first row here, this will be -1 to the power of 1 plus 2. So you will get sign here is negative, followed by positive, negative, and so on. For the second row, this will be negative, positive, and negative, and the rest is the same, where you have to find the sign of this position of element using this formula. So now, let us try this example. Given that A is equals to 2, 1, 3, 4, 2, -1, 2, -1, 1. From here, calculate the inverse matrix of A by using adjoin method. First of all is that you need to calculate the determinant of A. So to find the determinant of A is A11 times with minor 11 minus with the A12 times with minor matrix of 1, 2 plus A13 times with minor M13. So here our determinant is equals to -28, where the determinant is not equals to 0. Therefore, we can say that the inverse matrix of A exists. Since it is exists, so we can proceed with the next step. So the next step is calculating the minor matrix. So we find the minor matrix for all rows and columns. So first we found the M11 and then find the determinant of M11. Same goes with M12. After we got the matrix of M12 by deleting the first row and second column, and then we find the determinant of this matrix. So same goes with the rest of the matrix. So from here, we can conclude that the minor matrix is 1, 6, -8, 4, -4, -4, -7, -14, 0. So it can be simplified in terms of this matrix. Then after that, you can calculate the cofactor matrix using this formula, where for cofactor is just that you put the negative positive sign inside the matrix, inside the minor matrix. So for the first row and first column, the sign should be positive, this one should be negative, and this one should be positive. Here will be negative, positive, negative, positive, negative, positive. So our cofactor here will be in terms of this, where we just multiply the sign with the minor matrix. So our cofactor matrix will be like this. 1, and you can see here is -6. This one is -4, and this will be 4, and this sign is negative, so here will be 14. Then the next step is get the adjoint matrix of A, where adjoint matrix is getting by transposing the cofactor matrix of A, where we find the transpose of matrix cofactor. So here we will have the first row will be the first column. Same goes with the second row will be the second column. Then after that, substitute the result from step 1 to 4 into the formula of inverse matrix, where 1 over determinant of A multiply with adjoint A. So we get the inverse matrix of A in terms of this.